Namaste to everyone. I welcome you all in my YouTube video channel. Today, I will daily your lecture on probability, lecture number 9, in which I will apply the concept of permutation and combination for the solution of problems on probability. Before applying the concept of permutation and combination for the solution of problems on probability, I would like to give you a brief touch on the concept of permutation and combination. We have three letters A, B, C. We have to select two letters from these three letters. We may select AB or AC or BC. Therefore, number of ways to select two letters from three letters be 3. Here 1, 2, 3. This concept is called combination. Here number of ways to select two letters from three letters is 3. We denote this by 3C2. Number of letters be 3 and we have to select two letters. So if we have a number of things and we have to select r number of things, then number of ways to select these is NCR, which is equal to factorial n by factorial r multiply factorial n minus r. If in place of selecting two things, if we speak about the arranging two things out of three things, then we may arrange two things AB, AC, BC. Also, we may rearrange this AB as BA. We may rearrange AC by CA. We may rearrange BC by CB. So we get 6 number of ways. 6 ways. And this is called permutation. So we denote this as 3P2. And formula for this is factorial 3 by factorial 3 minus 2. Now, if we take both concept permutation and combination together, if it is asked that we have to arrange two things out of three things, then firstly we select two things out of three things, and that is the number of ways is 3C2. And then the number of ways to arrange two things is factorial 2. Since both works are simultaneously necessary, so we multiply the number of ways. 3C2 multiply factorial 2, and this is called 3P2. With the help of examples, we will show that how the concept of combination is used for the solution of problems of probability. We have a bag, and in the bag we have 4 red balls and 2 black balls. red balls are denoted by R1, R2, R3, R4 and black balls are denoted by B1 and B2. Let we draw a ball from the bag. Then we have to find the probability that that ball will be a red ball. Here S be the sample space containing 4 red balls and 2 black balls. So event will be a set containing R1, R2, R3, R4. And we solve this problem as probability of E equal to Ne by Ns, number of elements in event, number of elements in sample space. Here number of elements in event is 4, number of elements in S sample space 6, that is 2 by 3. This is the earlier process. Now if we use the concept of combination and then solve in this way, here we have to select one ball. Therefore, number of ways to select one ball out of 6 balls will be 6C1. So, in sample space, number of outcomes will be 6C1. And for event, we have to select red ball. Here, number of red balls be 4 and we have to select one ball. One red ball means number of elements in event will be 4C1. So event 4C1 by number of elements in sample space 6C1. 4C1 is 4, 6C1 is 6 and this is equal to 2 by 3. Same result in both cases. Now let a bag contains 6 balls, 4 red balls and 2 black balls. We have to draw 2 balls. Then what is the probability to draw 2 red balls from the bag? In this case, we make the sample space S 2 balls, that ball may be R1, R2, R1, R3, R1, R4, R1, B1, R1, B2 or R2, R3, R2, R4, R2, B1, R2, B2 or R3, R4, R3, B1, R3, B2 or R4, B1, R4, B2, B1, B2. Number of elements in sample space will be 15. Since we have to draw 2 red balls, then event will be for 2 red balls. That event will be R1, R2, R1, R3, R1, R4, R2, R3, R2, R4, R3, R4. Number of elements in event will be 6. So probability will be Ne by Ns, number of elements in event by number of elements in sample space, that is 6 by 15, this equal to 2 by 15. As here we see that we have to write the sample space, and if the size of the sample space is large, then it is very difficult to write in the copy. So to cope with this situation, we use the help of combination. For getting number of elements in sample space, we have to select 2 balls out of 6 balls, that is 6C2. So number of elements in sample space will be 6C2 here. And for event we have to select 2 red balls out of 4 red balls, and that will be number of elements or number of ways equal to 4C2. So probability will be 4C2 by 6C2. And if we solve this, 4C2 is factorial 4 by factorial 2 multiply factorial 4 minus 2, and 6C2 equal to factorial 6 by factorial 2 multiply factorial 6 minus 2, that is 6 by 15, that equal to 2 by 5, and we get the same result. Here we see that the first process is very lengthy, and with the help of concept of combination, the process will be very short. So in this case, we use the concept of combination and solve the problem. We do not have to write all the elements of sample space and all the elements of the event. Only we take the number of ways to select the required number of things out of total number of things. Now we solve a problem. Problem is a committee of 2 persons is selected from 2 men and 2 women. What is the probability that the committee will have number 1 no men, number 2 1 man, number 3 2 men? Number 1. Event is to select no man. We have to select 2 persons. So probability of this event E1 is no man means 2 women, to select 2 women. Number of women be 2, and we have to select 2 women. So number of elements in event be 2C2. Number of elements in sample space will be 4C2. We have to select 2 persons out of 4 persons. So this will be equal to 2C2 means factorial 2 by factorial 2 minus 2 means factorial by factorial 4 by factorial 2 factorial 4 minus 2, and this will be equal to, here factorial 0 means 1 and factorial 2 by factorial 2, this is 1 by, here we get factorial 2, here factorial 2 means 4, so we get 3 2s are 6. Number 2. 1 man. Since in committee we should have 2 persons. Here given that we have to select 1 man, then other person will be 1 woman. So probability of this event will be number of elements in event 2C1, 1 man out of 2 men, multiply 2C1, 1 woman out of 2 women. Since both works are simultaneously necessary, so to find the number of ways we have to multiply these. And in sample space, number of elements will be 4C2, and 2C1 means 2 multiplied by 2, and here 6, so 2 by 3. Number 3. 2 men means, let this event is E3. Event is to select 2 men. We have number of men 2, so we have to select 2 men out of 2 men. This is the number of elements in event, and number of elements in sample space will be 4C2. This is 1 by 6. Now we solve the next problem. Problem is 5 cards are drawn from a pack of 52 cards. What is the probability that these cards will contain just one S? Now we solve this. Solution. Since number of total cards be 52, we have to draw 5 cards out of 52 cards. So number of ways to select 5 cards will be 52C5. That is, number of elements in sample space will be 52C5. Now event. Event is to select one S out of 4 S's, means 4C1, and remaining number of cards be 48 except 4 S's. So we have to select 4 cards out of 48 cards. So number of cards will be 5. Since to select one S out of 4S and to select 4 out of remaining cards, 2 works are simultaneously necessary. So number of ways will be the product of these two things. So probability of this event will be 4C1 multiply 48C4 by 52C5, and this will be equal to factorial 4 by factorial 1 factorial 4 minus 1 means factorial 3 multiply factorial 48 by factorial 4 multiply factorial 48 minus 4 44 multiply. We write here factorial 52, here factorial 5 multiply factorial 52 minus 5 factorial 47, and by calculating we will get 3243 by 10829. Now we solve problem number 3. Problem number 3 is 4 cards are drawn from a pack of 52 cards. What is the probability that they are of different suits? Now we solve this. Since we have to draw 4 cards out of 52 cards, so number of elements in sample space will be 52C4. So out of these 4 cards, 1 card should be spade, 1 card should be clubs, 1 card should be diamond, 1 card should be heart. Since number of spade card be 13, similarly each should contain 13 cards. So event will be, we have to select 1 card from spade. Out of 13 card, 1 card spade, 1 card club, 1 card heart, 1 card diamond. So here we get 4 cards, and each work is simultaneously necessary. So here we have multiplication. Now PE equal to, probability of this event equal to 13 C1 multiply 13 C1 multiply 13 C1 multiply 13 C1 by 52 C4 NS, number of elements in sample space. Now we solve the next problem. Problem is that two cards are drawn from a pack of 52 cards. What is the probability that both the cards are either black or SS? Let the event to draw the black card be B, means black. Event to draw SSB A, we have to draw two cards out of 52 cards. Therefore, NS sample space is 52 C2. NB black card. Number of black card be 26. 26 C2, two black cards. Number of SSB 4. So to draw two cards out of 4 cards means 4 C2. But here the problem is related to total probability, because here both cards are either black or SS. So in B intersect A means card which are black as well as SS. So number of such card be 2. One black S is spade, other black S is clubs. So here 2C2. We have to select 2 black SS, means number of black SS be 2 and we have to select 2 black SS. Now P B union A equal to PB plus PA minus PB intersect A. This PB is NB by NS plus NA by NS minus NB intersect A by NS. NBB 26 C2 by 52 C2 plus NA 4 C2 by 52 C2 minus NB intersect A 2 C2 by 52 C2. Thanks for watching my video. If you are satisfied with my presentation and contents, then please click on like button and do subscribe my YouTube channel. Thank you.